You guys are welcome to type them in the chat box. Okay, J Thomas 81. If you're asking if I got it, please send me an email with your full name and your GID so I can make sure that I'm looking in the right section. And then that way I will check to see if I received the file. I'm not going to check right now. But if you want to know if the file went through, you can email me. You can also check yourself. If you go to My Grades, there is, when you're going to My Grades in the classroom, it will list all the assignments. And if there is a yellow circle for the week 1 assignment, that means that it has been submitted. If there's a yellow circle, that means it's been submitted, but it has not yet been graded. If you see a blue circle, like it looks like a piece of pie, that means it has not been submitted yet. It's been partially uploaded, or you started it, but you have not submitted it and turned it in yet. So you can always check yourself to see if the file has uploaded correctly. The other way you can do that is when you go to click on the assignment, if it's been uploaded, it will show you what you submitted so that you can see what you submitted. So that's another way to check to make sure that your work has gone through and that I have received it. Okay, John, you say you have so many questions, you're not sure where to begin. Are any of those questions related to content? If it's related to content and it is, we could start from the beginning if you know what chapter, what section it comes from. We can just start from the beginning and moving on. How are you guys feeling with order of operations or like the symbols that we use with the math? How are you guys feeling with that? Okay. Let's see. Debbie, do you have a question? I think should be able to unmute you. Or you can unmute yourself.
You mentioned order of operations. Would you just go over that, please?
Sure. Yeah, I can definitely go over order of operations.
Thank you.
Okay. Let me get my screen shared. Okay. I've actually was doing several order of operations problems today. So I'm going to just make up numbers. I'm going to just kind of do something a little complicated but with different symbols. So that way you can kind of see how each of these things are worked. Let's see. Okay, so I guess I kind of got bigger as I was writing. So there's this. So I have lots of things going on here. And I'll just order of operations. So the order of operations, we have a little like shortcut saying is Pemdas. P-E-M-D-A-S, which stands for a thing to remember. It is please excuse my dear Aunt Sally. So the P stands for parentheses, but it basically is anything that has grouping symbols. So if you have brackets, if you have curly braces, if you have absolute values, and absolute values are straight lines, so those are different from brackets. those are all in the grouping symbols under the P. And when you work those, you always work inside out. E stands for exponents, and it also includes square roots. So if you see anything with square roots, that's sort of done at the same time. M and D, so these go together and they go left to right, just like the same order that we read. And this is multiplication and division. So multiplication could be with a dot. Sometimes we use a star. Sometimes we have two sets of parentheses that shows multiplication. And then we have like division and fractions. Those also are considered division. So multiplication and division can be done as you go left to right. So sometimes division comes before multiplication. It's all going left to right. Then we have the A and the S, which stands for addition and subtraction, and those also go left to right in the order that we read. And so that's addition and subtraction. So the order of operations is a little more complicated than Pemdas. There's more nuance to it. So I have this very complicated looking problem here, but it's really not so bad. So we want to work inside out. So I'm going to just kind of highlight. We're going to look at the parentheses, all the grouping symbols. So the outermost grouping symbols are these braces. So everything that I've highlighted is within the curly braces. Now, the curly symbols, sometimes they're called curly brackets. The official name is a brace. So that would be the outside kind of steps. Then we can highlight sort of what's inside there. Inside there we have these parentheses, and then we also have brackets. So those are separate things, but they're both inside the curly braces. So when we say that we work inside out, we're looking at the innermost things. So we'd be looking at the orange things, and then once we simplify everything in orange, then we would simplify everything in yellow. So you work inside out until you've kind of removed all of your grouping symbols, the parentheses, the brackets, the curly braces, that sort of thing. So I'm going to start with the first orange set. So when we do the order of operations, everything that we are not changing, we can just write. And this 2 and then the curly brace, we are assuming that's multiplication. So if there's no symbol in between the number and the symbol, it's assumed it's multiplication. So I'm going to just put a dot there so that you can, that reminds yourself that is being multiplied. Okay, so my first orange, I have 2 minus 5 inside there. So I need to do that subtraction. So that 2 minus 5 is the same as doing 2 plus negative 5. It's going to put us in the negatives because we're taking away more than we have. So that is going to give us a negative 3. And then I have my exponent. Now I have my 3, and then there is a bracket. Again, if there's no symbol between a number and like a bracket or parenthesis or something, that's assumed to be multiplication. So I'm going to just write that dot there. And then I have my bracket, and now I want to simplify within the orange. So I have my 4 plus, and then I can do 5, and that's, again, there's no symbol between 5 and the parenthesis. We assume that's multiplication. So that's 5 times negative 2. So a positive times a negative is a negative, so I'm going to have a negative here, and 5 times 2 is 10, so that's going to be negative 10. So for following my highlights and my groupings, I still have everything in yellow that I need to simplify. And then I've simplified essentially inside one of the orange things with the set of parentheses, but I can still simplify inside the brackets because I have something that I can do there. I can do that addition there. So I'm going to do that as the next step. Because that's inside brackets, we're trying to get rid of all of our grouping symbols. Yes, Debbie.
Okay, back up there on where you say, though, you're supposed to assume that it would be a multiplication. The very first one you did, you added. You added 2 plus -5.
Yes, that's because it's a subtraction symbol there. We assume multiplication if there is no symbol in between. We have a symbol there, we have that minus sign, and subtraction is the same as adding a negative.
Yes.
So because we have that symbol, that's subtraction.
It's addition. No.
Subtraction is the same as addition. So 2 minus 5 is the same thing as doing 2 plus -5.
Okay.
So you can read those in either way.
All right. Thank you.
Do you have any other questions?
Many, but go ahead.
Well, if you still have questions on what we have, I want to make sure all questions are answered here before I move on.
I second her.
So before I go further,
my understanding of it, I think she's trying to say, why do we have to add it when it's a minus there? I know it's making that 5 negative, but it still confuses you when you see a minus. You know, you think you should subtract.
And no, I thought, though, I should multiply because there's no symbol there. 2 times -5.
It is a symbol. It's a subtraction symbol. If it was 2 times -5, there would be parentheses around that negative, like with the 5 and then the -2 on the right. Because we have a parentheses there, that's making it different so that you know that it's not subtracting 2, because there's that parenthesis in between.
Okay, well then my next question would be, I thought if we're working all the parentheses and first, wouldn't you change that in the second orange highlighted on the top line, the 4 plus 5 times -2? Okay, wouldn't you change that -2 to a positive first?
We can't turn a negative into a positive unless we're subtracting a negative.
I'm like, if I'm working the parentheses first, wouldn't I do something with that -2 in?
There's nothing to do to the -2 because you don't have any other symbols inside. You just have a number. When you're working parentheses, you have to have something that you can do inside them, like you're adding something or you're multiplying something. All we have is a -2, so there's nothing to do there.
Okay.
So those parentheses there are just making it clear that we're multiplying by a -2. We're not subtracting 2. Because if you don't have those parentheses, it now says 5 minus 2 instead of 5 times -2.
Okay.
I don't want to move on until I make sure I've answered all questions.
Well, I kind of get what you're saying there, and I'll try to work it that way. I mean, I have almost all mine done. I'm so confused on a couple of questions in the quiz and my homework, but I mean, that kind of cleared that up. I think I can work it another way, and I can look at it, try to look at it that way. But yeah.
Okay.
Okay, so yeah, will you move on with and show me how do you like turn that -3 there on the second line to the exponent of 2? Yeah.
Yeah, we'll do that next. I just wanted, before we move on, somebody else had spoken up.
Oh, okay.
And so I want to make sure if other people have any questions.
Oh, ma'am, you helped me out. I understand.
Okay. Okay. All right. So, I mean, a lot of this is just knowing, I mean, math is a very particular thing, you have to understand the rules and the difference between what the symbols mean, and like pay attention to where parentheses are, and it makes a big difference. So hopefully with practice, these things will get a little more clear. So with what I've got here, so the next step is, before I do the -3 with the exponent, we need to still simplify what's in orange, the 4 plus -10 that I have there. So I'm going to copy down everything else right now. Okay, and then once I reach that orange, I have 4 plus a -10. So since the 10 is a bigger number than 4 and it's negative, this is going to put me in debt again. So I'm going to end up with a negative number. 4 plus -10 gives me a -6. So I'm going to just make that a -6. Now, so far, I still have this grouping with my curly braces. And now I've essentially kind of turned in my parentheses and my brackets so that there's just a number in there. When you have just a number, you can't really do anything else inside. And that's where you move to the next step in the order of operations. So now that we've gotten our parentheses where there's only a number in there and the bracket with only a number in there, the next step would be exponents. So that means we're going to be doing this -3 squared. So I'm going to copy this down. Okay, so a -3 squared, that square means you're multiplying it twice. So it's a -3 times -3. So a negative times a negative is a positive. So we're going to get a positive number out. And then it means 3 times 3. So that's going to give us 9. So we're going to get a positive 9 out from -3 squared. So then I'm going to copy everything else here. So before I move on, are there any questions? Okay. So now I've still got my highlight here. Okay, John, you are saying PEMDAS does help greatly with the order of operations. Yes, remembering that acronym kind of helps you remember like what order to do things, but it is also important to remember that it's more than just parentheses, exponents, multiplication, division, addition, and subtraction, because we do have this left to right stuff going on. So we're still got this curly brace of the yellow that we're trying to simplify. So we're still working inside there. We don't have any more exponents. So the next is multiplication and division. So we don't have any division, but we do have multiplication. So now I need to do this multiplication to 3 times -6. So I'm going to copy this down. And then once I get to the orange, 3 times -6. So we have a positive 3 and a -6. So a positive times a negative is a negative. So I'm going to get a negative answer. And then 3 times 6 is 18. So I'm going to get a -18. So because of those brackets there, that's making sure we know not to subtract it, that it's multiplication.
Oh, Miss Stephanie.
Okay, hold on. I got a question in the chat box. Would 3 times -6 be similar to -6 cubed? Okay, so I will answer that question first. 3 times -6. So that gives us a -18. -6 cubed, that exponent, means that you are multiplying -6 3 times. So that is -6 times -6 times -6. And when you have -6 cubed, you first need to multiply left to right. So you have a -6 times a -6. A negative times a negative is a positive, and 6 times 6 is 36. So this would be 36 times -6. Then you would have to do 36 times -6, which, oh goodness, trying to do this in my head. I think it's -216. Let me get my calculator out for that. Yeah, you get a -216. So 3 times -6 is different from -6 cubed because they mean different things. Does that help answer your question, John? Okay. So now that I've answered the next question, somebody was speaking over the microphone. Go ahead. Sabrina, was that you? You can go ahead and ask your question.
So when does the bracket, even though it's a bracket, that still mean parentheses? Does that still mean that we supposed to still add within the parentheses, even though it's a bracket? You know, the bracket and the parentheses be confusing.
Mm-hmm.
Like,
Okay. Mm-hmm.
like bracket, parentheses, the math problem.
Mm-hmm. Yeah, so Sabrina is asking whether the brackets are basically the same thing as a parenthesis, and they basically are. So you can treat brackets as parentheses. Those curly braces can be parentheses. The reason why we use different symbols is because if I had written the original problem, so if I wrote the original problem and used only parentheses, it gets really confusing, because then you have parentheses inside parentheses, and it kind of gets confusing on where they begin and where they end. So you can see I just rewrote the same problem with only parentheses, and it's really hard to see where things are. So that's why we use different symbols, so that way you can see very clearly where each grouping is. But they have the same, they do the same thing. They're brackets, parentheses, curly braces, those are all the same. Absolute values are not, those are different. Those make things positive. But everything else basically is just a way to group it.
Okay, thank you.
So, yeah, if you want, you can always turn your brackets into parentheses. So if you don't like that symbol, you can make them parentheses.
Right, though, while the parentheses, they do look complicated.
Yeah, yeah. It's when you have that with that many parentheses, you really do have to kind of highlight and figure out which ones you have to match them together, and it's very hard to do.
Yeah. Thank you.
You're welcome. Other questions? Okay, so I can move on to the next step now. I still have the, oops, I want a color code here. There we go. We still have got our highlight of the yellow. We are finally at the spot where we can simplify inside the curly braces, and we can do that addition. So we can do 9 plus -18. So that's going to, again, I keep getting negative numbers here with these numbers I made up. 9 plus a -18 is going to give us a -9. So this will be 11 minus 2 times, and then I have my curly brace, -9. Okay. So now inside the curly braces is just a single number. And so once you've reached that, now we can finally move on, and then we go back with once again finished P, and then we move on and we say, okay, do we have any exponents or square roots? We don't have any exponents or square roots, so the next is multiplication or division. And so now we have multiplication. So that means we can multiply this 2 times a negative 9. So it's really important that multiplication has to happen before subtraction. So you're not going to do 11 minus 2 because that 2 is multiplied. We have to do multiplication first. So, and a lot of people kind of get confused with this minus in front of the 2. So you can think of this as a negative 2 times a negative 9, or you can read it as 11 minus and then a positive 2 times a negative 9. You can read it both ways. So if I'm looking at just as subtraction, I have 11 minus, and then I'm going to do 2 times negative 9. So if we think of that 2 as a positive 2 times a negative, we're going to get another negative. So I'm going to just put a parenthesis here because it's going to get a little confusing. And then 2 times 9 is 18. So by just the green, I have 2 times negative 9, that gives me negative 18. But I have this other subtraction symbol that came 11 minus that. So that's where that negative. So I have 11 minus and then a negative 18. So I'm subtracting a negative. Now when you're subtracting a negative, those negatives cancel out and that becomes adding. So that becomes 11 plus 18. So subtracting a negative, those cancel out. So now I'm just at 11 plus 18, and so now I can do that addition. That's the very last step. And so that will give us 29 as our final answer. So are there any questions? Yes, Debbie.
Go over that one more time, that 11 minus, how that became.
So we are subtracting and subtracting a negative always, those always cancel out and become a positive. That becomes addition. Because if you're thinking your subtraction, you're going to the left, and then a negative, the subtraction is sort of the same thing as thinking of you're taking the opposite. So if you're taking the opposite of a negative number, you're then getting a positive number. So that's how it also becomes a plus. So if you have two negatives, you're subtracting a negative, you can always turn those into a positive, and you get 11 plus 18.
Will that work out on a number line? Like
yes.
if I did that on a number out to 29?
Right. So what happens here, okay, so I'm on a number line, and let's say I'm at 11. And when you're subtracting, you're going to the left. But when you're subtracting a negative, instead of subtracting the opposite, so you're now moving to the right instead. Because subtracting a positive number moves to the left. So that means subtracting a negative means you have to then go to the right instead. So that means instead we're counting up to the right by 18, and that will eventually get you to 29.
No. Okay, I'll have to Google that, try to work that out again. Thank you.
Mm-hmm. Any other questions that are on what I just worked out? Yeah, Debbie.
Okay, Stephanie, but can you do something with like some negative numbers and square roots and stuff like that? So I can see that too, please.
Where do you want numbers in? Like, can you be a little more specific about how they kind of, like, do you just want an example of order of operations where there's a square root present, or?
Yeah. Please.
Okay.
and they like a negative number inside the square root, you know.
Okay. Well, if
See
you
how
just have
that-
inside a square root, you don't have an answer because we can't take negatives as square roots.
Okay, I'm sorry. There's like a whole problem in there with a negative number in parentheses or something.
Okay. Okay.
And some left with some negatives and minuses. I don't know.
Okay. Let's
So I can
see.
see something like that. I don't want to give specific examples, Stephanie, out of the book, but yeah, something like so I can see how that's done.
Okay. Kind of making this up. Let me make my square root look a little easier. Okay. So we've got -3, and then we have a squared symbol. So that is going to be, again, there's a number and then there's a symbol, so that we are assuming that is multiplication. And then we've got the square root of -4 plus, let me make sure it's better. And then these are absolute values because those are straight. So straights are absolute values, and then 2 minus 5. So order of operation is parentheses. We don't really have any parentheses here. So you would move to the next step, which would be exponents, or roots. And so our order of operations would be we need to simplify inside the square root before we do anything else. So we need to do that step first. And then we're going to go inside the square root. And inside your square root, we have absolute values, and that's considered a grouping symbol. So the first thing we're going to do is simplifying inside the absolute value. Okay, I'm going to mute somebody. I'm hearing, I can find where my mouse is. I was hearing somebody's child, so I'm going to just mute you. Okay, so we have -3 plus 5, and then there's nothing in between a 5 and a square root, so that's assumed to be multiplication, so I'm going to just write that symbol. Then I have my square root symbol, then -4 plus, and now I need to simplify inside the absolute value symbols. So I need to do the 2 minus 5. So 2 minus 5 is -3. We saw that before. So I have this absolute value of -3. So I'm still working inside my square root. And now the next thing I need to do is actually take the absolute value. So now instead of simplifying inside the absolute value, I have to take the absolute value. So once you have a single number inside absolute values, then you make that number positive. The absolute value always makes the number positive. And when you do that, the symbol disappears. So I have my square root -4 plus, and then that is going to become a 3 because that absolute value removes that negative sign. And so that leaves us, we're still inside the square root. So before I move on, there might be some questions there about that absolute value or what I just did. So are there any questions? Okay. So now I'm still trying to simplify what I have yellow, what's inside the square root, and I have addition there, so I need to add those. So I have a -4 plus 3. So I'm going to add those together. Ooh, because I made up these numbers, these are not working really well. I'm going to change that -4 to a -2 just because otherwise it's not going to work out. So I'm going to just change that so that I have a problem I actually do. This is the problem with making up numbers. Okay. So we're going to just change that -4 to -2 so that this actually works out. So you need to do -2 plus 3, which is equal to 1. So now I have the square root of 1. So now I've simplified everything inside the square root. The next step is to actually do the square root, to actually take the square root of 1. And the square root of 1 is just 1. So this is going to be 5 times 1. You can verify that on your calculator. 1 squared is 1, so the square root of 1 is equal to 1, because the square root kind of undoes an exponent. So now we have -3 plus 5 times 1, and multiplication always happens before addition. So I need to do this multiplication of 5 times 1. So I have a I have -3 plus, then 5 times 1 is 5. So now I have -3 plus 5. So now I'm going to add these together. -3 plus 5 will give me a +2. Okay. So John, you're asking, would Pemdas work with a problem like this? No, there's no parentheses. There is the square root in the x. We did just do Pemdas, actually. So when you have Pemdas, that's just a way to remember the order of operations. You don't have to have every letter in the Pemdas. So like for the P, we didn't have any parentheses, but we had a grouping symbol of the square root. And we had to work inside the square root, and then we had these absolute values. So if I go back here, I had put those absolute values, that's under the P. So we were using PEMDAS. When we did the absolute value part, that was part of the P part of PEMDAS. Then when we went to the exponents and we were simplifying, that's where we were able to do the square root. So we had to simplify everything inside there first. And then we were able to do the square root part of PEMDAS, which is part of the exponents. And then from there, we were doing the multiplication and the addition. So all of these problems with the order of operations, you're using PEMDAS. You're using the same rules where you have to work you're working inside out as much as possible. And then you're just trying to simplify them by you're always saving your addition and subtraction for last. And you're always doing your multiplication and division as like second last, and you try to do everything else before then. So long answer to your question, yes, PEMDAS works. Debbie, yeah, go ahead.
Are you talking to me, Stephanie?
Yes,
Okay.
go ahead.
I don't want to give anything away, but I don't understand the question on the quiz number 16. How do you, well, I don't really understand how to show multiplication to check division. I don't understand that.
So the definition of multiplication, so let's say I just have 4, no, let's not use 4. Let's say we've got 5 times -10. So 5 times -10 gives you -50. If you want to make sure that your multiplication is correct, you can take your answer and then you can either divide it by 5 or you can divide it by -10. And then that will check to see whether you did that correct. So if you do -50 divided by 5, you're going to get a -10. And if you did -50 divided by -10, you get a +5. So you end up by doing division of either one, you get the answer, the other one that was involved in the multiplication. So that's how you can check your multiplication to make sure you did that right, by doing the division and kind of undo it and make sure you get back to where you started.
Okay, thank you.
Mm-hmm. Okay, we've got about 10 minutes. Do you guys have other questions that are things that I can do in 10 minutes? Anybody have any other questions? If there's any specific questions about the quiz, those are best emailed to me.
So, Miss Stephanie, was those two problems that you put an example for our assignment? Were those our assignment math problems to do?
Okay, so I think this is so yeah, Sabrina, you're okay. So Sabrina, your question is those two examples. Are you talking about the problems that are listed in Blackboard or these that we just did here?
Yes, ma'am. The one that listed in Blackboard, I did it for my assignment, so I had assumed those two problems for the assignment for assignment 1.
Yes, that is correct. Yeah.
Okay.
So the two problems that are in Blackboard that I have like the template for, those are the exact problems that you need to do.
Okay.
Yes, go ahead, Debbie.
Okay, I just want to say thank you so much. You've been a big help. I feel like I've taken up almost all of your time, but if you just want to, like, table A1 in the book that's talking about repeating decimals, I don't really understand that table.
Okay, let me find table A1. Okay, I'm going to pull that over here. Okay, so table A1. Sometimes this book moves on me. There we go. Okay, this table is giving some common repeating decimals. So the line on top of a number means that number repeats forever. So 0.1 with that line on the 1 means that it's 0.11111 and it just goes on forever. That number, if you were to write it as a fraction, is 1/9. So it's just giving us those repeating decimals and what they look like as what they would be as a fraction. That's what that table is giving. So they're not every repeating decimal. There are lots of other types of repeating decimals. These are just the most common types that you would see. Does that help?
Yes, yeah, it helps, I guess. And okay, my final question: when in real life am I ever going to use one of these algebra problems?
Well, it depends on what your major is. What is your area that you're in?
Strategic communications.
Strategic communications. Okay. I don't know too much about strategic communications, but I imagine that it might use some data. You might have to work with maybe some finances or some numbers or something like that. And whenever you have to use data, you might have to get some statistics. And statistics use algebra. A lot of statistics use equations. You have to solve for various things, or you're at least understanding how an equation works so you can plug in numbers in order to get your statistics. And then there are a lot of parts of statistics where you're using a computer to make lines, and then you get equations that you can use for prediction, and those equations are actually algebraic equations. So algebra is used. I'll have to do a little bit more research into strategic communication specifically, but most every job these days uses statistics in some form, or you at least have to understand data and work with data and kind of analyze data, and all of those require algebra in some form, or at least understanding where the numbers come from and how you can use algebra to get those numbers.
Thank you.
You're welcome. And I know you were having problems with the chat box. I just want to point out that John said in the chat box, "You're awesome, Debbie. No need to apologize." So it's completely fine to ask questions. So don't apologize for that.
Okay. Well, they say there's no stupid questions, but I feel
There
like
isn't.
I'm
No.
really
No.
stupid
I mean,
about algebra.
no. It's really important for you to ask these questions because they may be questions that other people have that I did not know people were struggling with. So I need them asked so that I can try to clear up any misunderstandings before we go too far. So.
Well, you really helped me a lot, and I will email those things to you because I think if those are like little helpful things that I could use, I would want to know what those are. So.
Yeah. So if you can send me those screenshots, then I can at least try to. It's hard when you're trying to describe and I'm not seeing what you're looking at.
Okay. Thank you.
Yeah, you're welcome. All right. Well, what I'm going to do for you guys is I recorded the math portion of this so I can put that in the classroom. And that OneNote that I was putting all these notes on, I'm going to, when I email, I'm probably going to email it out tomorrow morning, but I'm going to include that file with it as well so you have that as a reference. So that way you'll get that as a PDF, and then you'll have a reference of those order of operations and those notes that I was taking with it so that you have access to that. So thank you guys. I really appreciate that you guys made time out of your busy evening to come. And actually, let me open up my calendar to let you know when my next one is. Where is it? Okay, so I'm going to do it next week, and I'm actually going to do it on Monday at 6 p.m. Instead of Tuesday at 7 p.m. next week. That was a little bit more popular as more people are filling in that survey. And that's actually right before my office hours. So then, after that, we can do some extra time if I need to do one-on-one with somebody after that. So, and that one, I'm going to specifically talk about properties of equality. So that one's going to be a little more guided on a specific topic, but there will still be opportunity for you guys to ask questions afterwards. So that's that. So thank you guys again so much for coming and asking questions, because you asking questions makes me a better teacher, because then I know where the struggles are and I can try to address those in future courses. So I really appreciate all the input and questions you guys are asking. That really helps me out. So all right, well, all you need. Oh, you're welcome. And all you have to do is just close your window to pop out of here, and I'll try to get this out to you guys as soon as I can tomorrow morning. And hope, you guys have a great night. All right. Bye.